All right, students, these are Tuesday night's notes for Wednesday's class. And tonight we're going to be talking about another one of the transformations in the Cartesian coordinate plane. And this time we are talking about reflections. Our objective, the student will learn to apply reflections to objects in the Cartesian coordinate plane. Wednesday's date will be October the 2nd. Please write down your objective and your date, and press pause anytime you need more time, and then hit play when you're ready to move on. Okay, basic review here. We also mentioned this stuff yesterday, so if you already copied it in your notes, you probably do not have to copy it again. But the name for the XY axis that we've been graphing on for several years is actually called the Cartesian coordinate plane. Any location in the Cartesian coordinate plane can be plotted by an exact location lining up with the x-axis and the y-axis, and when you put those values together, it's what we call an ordered pair. The x value and the y value have names of their own. They are called the abscissa and the ordinate. We also said that when we are performing transformations in the plane, there's a basic rule for how the figures are named. When we have a pre-image, which is an object that has not been transformed yet, it has capital letters for its corner points, and then after a transformation has operated on the pre-image, we then call it an image, and the same corner points are still labeled with the same letters, but they are then denoted by prime markers, indicating that something has changed them. They have been transformed in some way. And then if more transformations happen, they will use more and more prime markers like double prime, triple prime, and so on. Okay, so let's look at a couple. Reflections. Okay, obviously the idea of reflection is similar to looking into a mirror. And as long as the mirror is horizontal or vertical, it's a very easy idea. Okay, just like when we did reflections the other day, when we were first talking about transformations. Okay, when an object looks into the mirror, or a point of that object looks into a mirror, what will it see? It will see itself the same distance out of the backside of the mirror. Okay, so here we have a triangle, and we are told to reflect triangle ABC through the y-axis. Well, these three locations, point A and point B and point C, they are all going to look into the mirror. And as we said, they will see themselves coming out through the backside of the mirror the same distance and direction as they are away from the mirror. So point A, point B, and point C, they look into the mirror and they come out of the backside of the mirror, and they are located at A prime, B prime, and C prime, coming out of the other side of the y-axis. Okay, we can then connect the three corner points, and we have our new triangle. All right, so the only thing really left for us to do is to identify the corner points of our new triangle. Well, let's have a look. Where is A prime? Okay, where does it line up with the x-axis? And then where does it line up with the y-axis? Okay, you probably have to count it out there on the x-axis to be sure, but it looks like it's out there at +6. And what about on the y-axis? It's going to be up at 2. So A should be at, or A prime should be out at 6, 2. Okay, how about B prime? Where does it line up with the x-axis? Appears to be +4. And how about the y-axis? It appears to be +5. So B prime should be at 4, 5. And then C prime, where does C prime line up? On the x-axis, it lines up with 1, and on the y-axis lines up with 3. Now you can compare the points, the coordinates that we just came up with A prime, B prime, C prime, and you will see many of the same values with coordinate A and B and C. And when you're reflecting through the x-axis or the y-axis, that's kind of an easy double check that you can do for yourself. What you have to remember as you reflect through either one of the axes and move into a different quadrant, the positive and negative values on the abscissa and the ordinate are going to change according to which quadrant you happen to be moving out of and moving into. Okay, slightly more complicated if you happen to be reflecting through one of the diagonals running through the graph. The one that's shown here is the parent linear function y equals x. It's called a parent function because this is the most basic format for a line. Its slope is +1. It has not been moved or sped up or slowed down. It passes through the origin, not anywhere else on the y-axis. It's not upside down, doesn't have a negative slope, anything like that. This is a line that when test writers try to make us do transformations inside of the Cartesian coordinate plane, very frequently they will use the line y equals x, the dotted line shown here. Okay. Well, the instructions say to reflect through y equals x. Okay. In order to accomplish this, it's actually not as difficult as it seems, but it's just something that's not exactly common sense. And what will happen is the abscissa and the ordinate will switch places. Okay, so let's look at A prime. Okay, actually the easiest way to do this is to look at the coordinate for A and figure out what is the coordinate for A prime going to be. So instead of moving the points like we did on the previous example, okay, now we're actually going to figure out the coordinates and then we can come back and plot the points. Okay, so point A is at -6, 2. Okay, so where is that going to put A prime at? Now remember, since the reflection is through y equals x, okay, the abscissa and the ordinate switch places. So instead of -6, 2, A prime will be at 2, -6. How about B prime? Well, have a look at point B. Where's point B at? Obviously, -4, 5. It's labeled in the picture. So what will the coordinate of B prime be? Abscissa and the ordinate are going to switch positions, so we're going to have 5, -4. Okay, how about the location of C prime? Well, look at point C. C prime should be at 3, -1. Now, having the coordinates, we can take those to the graph and we can easily plot those points. Having the points plotted, we can connect the dots, and we have our reflection. Really not all that difficult. It's just something new, so something we got to get stashed away in our memory banks. Anyway, quick notes tonight. I appreciate you finding some time to get them done. I will see you in class on Wednesday.